My name's Kurt Greschel, and I've been working on the design for the Metropolitan Park Level 4 skylight. And I've got like a little crude representation of it here. And I just want to start going through some of the things to coordinate the opening. Obviously, with this one, it's an unusual geometry, and we're trying to line up all the folds of the glass into nice sharp corners, which can be very challenging to do and coordinate. So there's a lot of special attention to detail, and I wanted to run through this quickly. I've done other projects like this, so I do understand what needs to be done. This is one that I did in Gettysburg, Pennsylvania a few years ago. It's a little bit bigger, but it has the same idea of triangles intersecting, but there's no prismatic geometry that lets the layers of structure work in concentric layers. It's all got to be independent, and as you get to the frame, it doesn't look like it's going to line up because you have to work back in parallel with the glass, which can be unusual if you're not used to it. But the goal is that as we get back to the steel, we get the steel located where it needs to be. It has to be erected exactly per the design. And then when we start putting that aluminum frame over, it's building back towards that sharp edge of the panel that you see here. And it can be a little off-putting. You look at it and you're like, well, why am I 8 inches offset? But that's because you're working back to different planes, and because it's not a prismatic structure, it's not concentric, so there's some weird things. But if you plan it right and carry everything through carefully, you can get all of these facets to line up in nice, sharp, crisp lines. And that's what we want to do with this project. And this is the first step to that. Here's the model that I've been working on of the Metropolitan Park skylight. I think I understand where we need to go with the steel, the concrete, and the skylight. Each part has a different task, and each one has to work with the others in certain ways. And then there have to be just some smart adjustments made at key points, which I'll go through in a few minutes. So please bear with me. I'll try not to make it too textbooky, but it is a pretty dry subject. So with these different glass planes, if you would take any two triangles, you get a triangle of glass here and here, and then there'd be an angle between these two planes. And if we would put frame here, we'd want to split that angle to support the glass evenly on both sides, which would set the axis of the bar running here that's holding the glass at a certain angle in space. Then if we take these two planes, it's going to have a different angle between those two surfaces, and that bar will be tipped to a different angle than the one above it. So these two bars are skewed in three-dimensional space, and as we try to bring them together at this knot, they're going to miss each other. You're not going to be able to miter those together. They're not concentric like a layer of an onion as you peel back. So that leaves some problems for how to do the frame, because you can't have that when you go to your structure. If we would set the steel up, let me get you a different picture and maybe show a little bit different how that looks. This was a sketch I sent to my engineer. And we have our glass with this number 2 pointing to our fold in the glass. And this yellow bar, that would be a glass frame member. And we've split the angle to support the glass evenly. But like I said before, when we would go to the next detail, that bar might be tipped a little different and they won't intersect. The only thing that intersects cleanly on this job is that little red dot, and then any planes coming off it like a sheet of paper. So we would come back and put the steel back here on that splitting bisecting line. Then those steel tubes will miss each other at the node points, and I imagine that would be a problem for the engineer record, because he's going to need to connect some of these to create moment joints to carry his load. Now the way we found that we can do that is if we take a vertical line, we can take this same geometry at this point, push it down here, and now these tubes will meet at those same clean intersection points so that they can be connected. And that's what we've done with the geometry here. We're not going to use the steel on a bisecting line, we're going to go on a vertical line. The aluminum glazing is going to be on the bisecting, and you can see some of the connections get a little weird. Don't let that throw you. This is a very preliminary sketch, and we have some ways to work with this that I think work really well. So, just to summarize, the aluminum glazing frame is going to bisect all the glass planes. Those joints will not miter cleanly at certain nodes. The steel is going to drop vertically, and that will allow nice connections at node points. And we'll get more into that with the 3D model in just a minute. Thanks. Okay, I've switched over to my 3D model. It's in AutoCAD. I will share this with whoever would like it. I think it would be good to share it with the steel guy. Hopefully he can use it. I can also export the solids in a different format that maybe he can input into his program. That's been successful in the past to help coordinate things. So here's all the glass planes, and we still have our points. And as I turn those layers off, you'll see I have a wireframe built that describes the skylight shape. And I've got that over the concrete curb, which I'm also going to turn off just so we can just focus on the wireframe and space. So those are our glass joints. Now, when I did the steel as a bisector, I can turn on those lines and you'll see that they don't meet up. They all kind of came back, splitting the angles of their planes, and they just miss each other enough that it doesn't look good if you try to build anything that way. You're going to get no steel connection that looks like anything you want to build. If anybody wants, I can show them that it's kind of lumpy, hard to work with. So we don't want to chase that with the skewed lines bisecting. We're going to get real close to that look anyway, and so we can let this part of it go. So let me go back and turn that off. Okay, I realized that was my first try wireframe and I was going to run into trouble. So I quick turned it off, and now we're back to the final design, and that's our glass wireframe with all the glass joints shown. And now let me bring up the steel wireframe that we are going to use. And you'll see it's all here. The pink line is 15 inches below the purple. Originally, the first one we tried 13.5, and the skylight frame was clashing with the steel in a few spots because the steel doesn't always go where you would like it to go, because it's going vertical, and it sometimes clashes with the aluminum that's bisecting the angles. By going vertical, the center lines all meet at a nice point. I'll explain these green lines as we go a little later. They are important to making this work. So what I tried to do with the steel is I've modeled it as tubes 1 through 10. So let's put 5 and 6 up first. 5 and 6. And I'm going to turn off the glass wireframe. And these tubes miter nicely. You wouldn't expect it. But if we create a plane and we take that work point and that one as the x-axis and this one is y, it's just a simple cut on the tube. They can be butted together and welded, and that would make a bent right there. That's one of your main structure pieces. You can do the same thing if you take the steel for line 4 and line 1 and also 7 and 10. And now you got 2 more bends, and they're going to kind of go from corner to corner and up to this apex. And then we got number 4 is green, number 7 is yellow, and they would get coped to fit around 5 and 6. And that's a nice clean joint. It can't be easy for the steel guy to cut those intersections, but it's doable. These are nice cuts, and the curb anchor, I don't know that anybody's really thought that through just yet. So that's your main structure right there, and it's intersecting pretty nice. So let me turn on some of the skylight bars for you. Bear with me. My eyes ain't so good. And these are the ones right above all of that. So like I said before, when we bisect the corner, these two hip bars for the aluminum will not intersect. See how badly they miss? You can't do anything with it. But I have a way to work around that. The important thing is, because the green steel is the same wireframe as the glass, these two bars are running parallel. These two are running parallel. They're running parallel with the glass plane if I would turn that on. That's what we got to maintain. We don't want everything running in a different direction. And if we set the steel wireframe and don't do the vertical drop from the glass, all of a sudden this end walks over and then the bars aren't running parallel with each other. So I'm going to go over to some details, and you'll have some drawings, and I think this is labeled 2, 3, 8, and 9. And we're going to just look at some detail cuts that I made. And this is detail 2, and you'll see where I double barred the glazing frame. There's a lot of reasons for that. I want to let it I want to drain out the upper section here, and I also want to let it expand and contract. I don't want to try to move it all through here. Now this is the theoretical node point where the steel would be, and what I did is I let it come here, and because this one isn't making a bent with anything, it's just a span between the other steel tubes. If I just slide it in plane, I can move it over to get it to line up with the skylight bars better. And you can see some of the weird stuff because of the different planes. They're all different heights. Yet the steel all dropped the same amount from the glasswork point. And over here you'll see number 9. Same thing. They're all a little bit different because there's no concentric geometry to work with. Everything wants to go its own way. So what we did is we've dropped it and moved it. And now we'll go back here and let me turn on those tubes, and you'll see what I mean, because we just walked them up. Now it looks a little funny, but I think when we get finished it won't be too bad. This is the worst one, where it, by worst I mean that it moved the most to get it centered underneath the skylight joint. And that's just a function of the pitch of the glass. You know, this is pretty steep, that's at 128%, and then this one's pretty flat. So the midpoint walks pretty quickly up the hill. But if we flip around and look at it from the bottom, you'll see the joints don't look too bad. Given what it is, I think it's a doable design. I don't know another one either, so it's sort of like it's good because it works. There isn't another option to really go with. So let me turn on the rest of the skylight bars. And now let's go look at it from the bottom, and because with those double bars, they read a lot nicer. They're going to sort of all be one sight line, and the steel's going to move around within it, but I think it still looks pretty good. And what's happened here, where the two bars in the aluminum frame that don't match, I can just clip them together in this space that isn't visible. And again, these bars don't have to make a structure, so I can piece them in each triangular plane. And then the only place we got caught out is at the apex, because I can't take these two bars, which are bisecting it, the geometry, but I can make a little standoff that catches them. And I think that'll work pretty nice to support the frame. We'll just let the glass come over the top and it will work out nicely. And that'll support back to here. We'll have to figure out how to cope the aluminum around that, but I can do that after I do the detailing. So right there, you're starting to see the skylight frame take shape, and we'll turn on a few more items. And there's your concrete curbs. So there's the frame. And if you look here, you'll see it gets real close. There's about 1/4 of an inch from that green tube to the bottom of that one. And I'm okay with that. I don't want to push it any further down, because as it goes down, it just sort of keeps expanding the envelope that we're working with, and there's going to be a tight spot. We'll do something with it to get some room. But right now, this is a coherent design. The concrete and the steel work together, and the aluminum works with the steel, and the aluminum supports the glass. And then when they land on the concrete curb, I can actually make a curb bar that comes together, because my planes will terminate here. Oops, grabbed the wrong one there. So my glass will be here. I can let this bar come into that corner. It doesn't frame out correctly, but it doesn't matter because it's in that dead zone where it's going to be a panel. And the panel joint will come together right with the glass. It just all gets squeezed a little bit here right at the end. So that's a pretty viable thing, and the attached drawings you have coordinate the concrete. I'd like these little corner things pushed down so our flashing can go around the corner. We don't want to have a big flat surface letting standing water and have wind blow water back at the joints in the skylight. You want to let there be a curb to drain, and then hopefully this is close enough. I do not know how the engineer wants to connect the steel to the concrete. I have just cut it off at this surface for now. But they're all going to be a little bit different because they're matching the glass planes, and they all have their own pitch even though they're all working together. So if you kind of look, there's a part of an intersection, but they all get sliced off by the concrete wall. It's definitely a challenging frame, but this is, in my opinion, the only option to move forward. So I would like you to kind of look it over, look at the drawings for coordination of the concrete and the steel. There's notes on there to help tie everything together. You'll have this CAD file. If you look on this layout tab, these are all section cuts through each of the details, and I'll give you a key. I'm not set on any one bar, and I'm still waiting for my engineer to verify all my little standoffs. He's on vacation for a week, and I didn't want to wait for him. But these details here, 2, 3, 8, 9, and then 6, those support the most bars. 4, 5, 7 are the problem bars, but they don't have a lot of connections on them. So that they're the tightest to the frame, but we don't have to connect too much there. So I let those be tight. These fit good. Number 1 and 10 fit nice, just like number 6 does. And then you got the curb details down here, and we'll work out how to make a nice termination coming off of here. This is the work point of the glass, lines up with the face of concrete, kind of following the layout that was on the architectural drawings. I think that's about it. I guess I can turn on the glass. And that is one layer too many. The bar pattern is particularly laid out. We want these intersections where they hit at a low point to be square. That will help me drain water out of the system. At a high point, I can let the bars intersect skewed because water's going to start there and then flow to here where I want a 90. Um, so I think this triangle has a different direction on the bars, but that's the only one that was really very noticeably different. These I put pretty close to what was there, and I played with the spacing a little bit to even them out. I think it looks pretty good. It's a little uneven here, but not too bad, so that the corners came clean, and this little chevron area caused a little trouble, but I think there's a good balance there. Um, we could discuss other spacings, but I really could not find another one. I've tried 10 or 12 different ways to do it. So, thank you very much. Hope it wasn't too boring. I guess what I'm looking for is just sort of a go-ahead that we're okay with this design. We should proceed, and that the steel will be coordinated per this model and the attached layout, and that the concrete will be coordinated per this model and the attached layout. That should allow the engineer of record to do his 4 anchor details here, and then the steel guy will be good to go, I think. So again, thank you very much.